Hi everyone, I wanted to do this quick video to go over the summary of the factoring techniques that we covered in class. This should provide a framework for you. Every time you've been told to factor something completely, you can go through this series of steps, and that's the best way to ensure that you have, in fact, factored this polynomial completely. The first thing that you want to look for is a GCF. If the polynomial has a GCF, you want to factor that out first, and that'll make the rest of the steps a little bit easier to follow. The next step, or if it doesn't have a GCF, the first step, would depend on how many terms this polynomial has. If it has two terms, you're going to look for difference of squares or sum and difference of cubes. If it has three terms, you're either going to use a guess and check approach or the ACB approach. It's possible you've been given a prime trinomial. If it has four terms, we did say in Math 21, if it has four terms, this polynomial is factorable by grouping. Once you've gone through this step and you've done that factoring, you want to look and make sure that the polynomial can't be factored further. And I'll give some examples of that below. But this is a good time to take a step back and make sure that what you did does work, and also that you can't go any further. Finally, though, you do want to consider, if you've done everything else, that it's possible that this particular polynomial isn't factorable using integers. So I have a series of example problems here that are supposed to illustrate a lot of these steps above. The first one, this does have a GCF. So the GCF is y. When I factor out that y, I end up with y squared minus 1. Now I can move on to that second step, which says how many terms are there. Well, this polynomial has two terms. And so I'm looking for difference of squares or sum and difference of cubes. And in fact, this is difference of squares. So this can be factored into y minus 1, y plus 1. I double check. All of these are factored completely, and that is the answer to number 1. When I'm looking at number 2, this is a four-term polynomial, and we said in Math 21, our four-term polynomials can be factored by grouping. So the GCF of this first group is y cubed, and I'll get y plus 1. The GCF of the second group is negative 8, and I end up with y plus 1. So the GCF of this group is y plus 1. What's left over is the y cubed minus 8. And here's where that step, is it completely factored, really comes in. Because this is completely factored, but this term isn't. Because that's a two-term polynomial, which is difference of cubes. So I'll repeat the first one, and then with the second one, I'll use that pattern. And the pattern was just take directly down what's been cubed, which would be y minus 2. And then we have the pattern where we square the first here, we square the last there, and then we do first times last, and then those SOAP signs, same, opposite, always positive. So this is the correct factorization of number 2. Moving on to number 3. Well, again, this looks pretty confusing. It's a three-term trinomial, so my first instinct was maybe to do some guess and check or ACB, but then I noticed that this actually has a GCF. So when I factor out the GCF, which is 4, that makes this trinomial a lot easier to work with. So this trinomial is actually a pattern that I recognize, and the pattern that I recognize is a binomial squared. If you didn't recognize that it's x minus 3 quantity squared, you would maybe have to go with a guess and check or even in the ACB route, but I did recognize this, so this is the answer to number 3, the fully factored form. An alternative statement of that answer could be like this. Either one of those would be acceptable on a test. Usually we prefer the first because it's a little bit shorter. Moving on to something like number 4, while there's no GCF to make this any easier, this is a trinomial, and boy, I'm just not up for guessing and checking this. So I'm going to use the ACB method. So this method says I take A and multiply it by C, giving me a negative 12, and compare that to B, which is 1. So I need two things that multiply to be negative 12, but add to be 1. I can already see those are 4 and negative 3. So those aren't my factors. That's how I rewrite or unfoil this, make it a four-term polynomial that I can then use grouping on. The GCF of this first group is 2x. I get 3x plus 2. The GCF of the second group is actually -1, and I get a 3x plus 2. Now I have a GCF of 3x plus 2. What's left? 2x minus 1, and that is the fully factored form there. Did you catch my mistake? That should be a 2. Moving down. So there's no GCF with number 5. So I go on to the next step, how many terms? And this is 2 terms. So it tells me that I should be looking for difference of squares or sum or difference of cubes. Well, these are squares, but it's not a difference, it's a sum. So in fact, this was one that is actually fully factored as it is. So I have to answer those somehow. So either I circle this saying that, yep, my answer is y squared plus 25. That's the factored form. That's as factored as I can get. Or I could even write, not factorable further. And that would be good enough for a test. Moving on to number 6. Well, this example has 2 terms again with no GCF, and this is still a sum, so I want to compare this to the one over here, number 5. But there's a big difference. It's not squares, it's cubes. So what is being cubed? Well, I've got something cubed here and something cubed there. Whoops. It's 5. 5 is being cubed. What's being cubed here? Well, it's y squared being cubed because 2 times 3 is 6. So using that property of exponents, I would get that y to the 6th. This is the one where I just repeat the pattern, bring that y squared and 5 directly down. Then I square the first, square the last, and then multiply them together, soap the signs, and I have the factored form of number 6. So if you have any questions, please feel free to send me an email or talk to me in class, but I wanted to post this video to just give you a little bit more factoring practice and a little bit more background on how to work the Summary of Factoring Techniques system.